Hello scientific audience. So let's discuss problem 1.14. Here we have a uniform electric field and the direction of field is always from positive to negative. So it is in the downward direction. So this is our electric field, and electric field means the direction of force which is being experienced by unit positive charge. So if I put a positive charge somewhere over here, it is going to experience a force in the downward direction. Had it been a negative charge, it would experience a force in the upward direction, and that force F would be equal to EQ, where Q is the charge of the particular particle. So this is particle number 1. Let's assume its charge is Q1. This particle is particle number 2, and this last particle is particle number 3 having charge Q3. Now first thing is we are supposed to identify the signs of the charge. Now it is very easy since opposite charges attract each other. So Q1 and Q2, since they are going up towards positive, which means Q1 and Q2 are negative. Right guys? And Q1 and Q2 would be experiencing a force of Q1 times E, Q2 times E. In which direction? In the upward direction. And now since Q3 is going towards negative, which means it is a positive charge, it would be experiencing a force of Q3E in the downward direction. Right guys? Okay. Now if I consider any charge, and let me say one thing, that if I consider this plate as A and this as B, the length of the plates is suppose L. The length of the plates, whether it is A or B, since they are same, I am going to consider the length as L. Now there is a charge which is initially entering. Suppose this is our charge Q3, which is entering the plates like this, and now it is bending. So say it is bending down like this, right? Now if you look at the displacement of the charge, it has got two components, one along y-axis and one along x-axis. So the displacement is along negative y direction. I am going to call it as y, and in the x direction its displacement is equal to the length of the plate. So if this charge comes out of the plate, this is the charge is entering from here, and when it comes out of the plate, it has got two components of displacement, x and y. Now x component is equal to length, y component is say y. Now guys, this we are supposed to establish the relation between y and charge by mass ratio. We are supposed to establish this relationship. Now guys, if you look carefully, that these all three charges were supposed to go straight. If there would not have been any kind of field, these charges would continue to go straight. But now since there is a field, they are deflecting. They are deflecting from their original path, and the deflection is noticed along y-axis. And from the diagram, it is visible that the deflection of the third charge is maximum, because the third charge is very near to plate B, whereas the charge 1 is comparatively far away from plate A. Right? So y deflection is maximum for charge number 3 as it is more closer to the negative plate. That means it is being deflected by maximum amount. That is very well visible. Now guys, we are going to establish the relation just like the equations of the projectile motion. That would be very easy, don't worry. So this charge Q3 would be experiencing a force of Q3E in the downward direction guys. Weight of all these charges are to be neglected. So this is the only one force acting on the charge in the downward direction. So as per Newton's second law, the resultant force is this force, and it can be written as mass of the charge, that is mass of the particle, multiplied by acceleration of the particle, that is equal to Q3 into E. Now we know that this force is along y-axis. To be very specific, it is along negative y-axis. So this acceleration would also be along negative y-axis guys. So this is the acceleration due to the force, and it is along y-axis. So from here we can say that the magnitude of this acceleration is this. and then we can say that there is no acceleration along x-axis, guys. Now this, since the charge is entering horizontally, so its velocity is purely along x-axis. Initial velocity, the charge when it enters, it has got initial velocity horizontal, so purely x component, and again no y component of the initial velocity. Now guys, we are almost done. We know that s is equal to ut plus half at square. This is the equation we have been studying from grade 9. And if I split this displacement, where s is the displacement, if I write it along x-axis and y-axis, this equation will be uxt plus half axt square, and this becomes uyt plus half ayt square. Now if I use this values of ax and ay to reduce this equation into x and y, so x is equal to uxt plus ax is 0, so the rest part will become 0. Y is equal to uy is 0, so this part will be cancelled, plus half into ay, acceleration along y-axis is q3e upon m3, correct, and multiplied by t square. Now guys, what is x? X is equal to L. Why? Because when the charge enters and when charge leaves, its x component of the displacement is L. So from here we can find out the value of time, and that time will be equal to L by ux or u, because I have considered the initial velocity as u. You may choose to write it as ux or u1 and the same thing, correct? So I am writing it as u. Now this value of time I am going to use over here. So y is equal to half into q3 upon m3 into electric field into L square upon u square. Now guys, everything is constant. When the charge enters, its velocity is constant. Let me use another pen to show you. So initial velocity is constant, length of the plate constant, electric field constant, half is constant. So we can say that y is proportional to q by m. So now y is maximum for 3. That's why q by m ratio for charge number 3 is the highest. This is how we prove the things, guys.